Hi, everyone. I hope you guys are having an awesome Friday. Oop, that's the bell. I'm going to close my door here real quick. Okay. Hope you guys are having an awesome Friday so far. So, today, what we did was I was interested in starting a new topic, however, redox reaction, but we'll start that on Monday. Okay. So we did one last percent composition activity, and it analyzes black ink really black. Okay. Is black ink really black? Now, obviously, you won't be able to do this research project at home, but how you set it up is, let me go grab one of our apparatus that we use. Okay, so we used like a pencil, and you would tape blotter paper to like a piece of paper, tape it to a piece of paper, and you would stick it down in a beaker. Okay, down in a beaker to see what happens. Now, we used three different types of ink. We used a Sharpie, we used a Crayola marker, and we used a crazy art marker. Okay, to analyze, is black ink really black? Okay, so from the results, this is what we got. Okay, this is what we got. So, like I said, this was taped up to here, right? And this is how it was dipped down in. This is the result. So as you can see, the very first one over here, this was a Sharpie. Okay, it's still black. Okay, still black. It didn't move any. So when we put this in water, that didn't move. Okay, if you look at the Crayola's in the middle. You can barely see where the dot started. The dot started down there. Moved all the way up, and at the very top now, there's a blue, greenish color. And then down here, you have the crazy art marker, where you got like blues and yellow, purple. That's kind of like a purple, actually. Purple and yellows. Okay. And the reason is because water, these two were nonpolar substances, so the water actually repelled it up, like as the water went up. And this was very polar, so it just kind of stayed put. So if we put the Sharpie in like a isopropyl alcohol or something like that, the Sharpie would have changed the colors and went up, and the other two would have stayed the same. So definitely an interesting factor. So if we look at this one, based on this data, the percent, right, we're talking about percent composition. The percent composition of black in this dot is 100%. That's still 100% black. That's still, I mean, that's just that. It is what it is. But if we look at the other two, what percent composition do you have? Well, this one's 0. There's no, I mean, I'd say there you got some darker reds, but there is not a single black in that color. And here, there's not a single black. So the percent composition of black in a black Sharpie is 0. But then how does it draw black? That's the question. When you use like a Crayola marker, a black marker draws black. But if the percent composition of black is 0, how does it work? And it works because black is made up of all colors. Black is made of all colors. So if you look at this example, there's so many colors that make up black. So there's 0% of black in black, but there's 100% of all the other colors that make up what black is. It was an interesting lab experiment to analyze the different percent compositions of ink and how they factor in. So that's what we did today. All right. So on Monday, we are going to start talking about redox reactions. I'll have a little presentation of that. We're done with multimole conversion, stoichiometry, and we're done with percent compositions. Okay. We're going to move on to redox reactions. And that's what we got. It's crazy. We only have 7 weeks and exams after this. 7 weeks and exams. That's pretty crazy. Time flies when you're having fun. So that's all I have. There is no assignments that you guys are going to be doing. If you have any questions on this experiment, the experiment was called paper chromatography. Okay, so if you're interested in looking that up, definitely, it's a really cool experiment. But anyway, I hope you guys have a great weekend, and we'll see you guys on Monday.